In this tutorial, we'll just go through some of the basics of R, as well as just some basic things that you could be using with simple linear regression. So after you open R, this is what the console will look like. The first thing that you should actually do is to establish or set the working directory associated with R. So the working directory is basically the path or the folder from which R will be loading all data sets from, or where R will be saving all output to. So basically you have to set a particular path or folder as the working directory. So whatever commands you type in later on when you ask R to load a data set to save certain files, it will load or save the files to that working directory. So that's something you should always do. A few ways in which you can go about doing this is you could look under File and Change Directory, and once you click on this link, it'll allow you to pick which path or folder you want as your working directory. So that's one way of doing it. Another way you could do it is to use the set wd command, which is set working directory, and then you could just manually type in the path of the working directory. So you could do something like this and finish the, just type the whole path. I personally don't use that because it's a little bit long. But once you set your working directory, you can always confirm it by typing get wd, open and close parentheses, and then press the enter command, and that would show which path is your working directory. Okay, so that's one way. Sometimes you forget which directory, what's your working directory. You can always type this in. To execute any command in R, right after typing the functions, you just press the enter button. So I'm not going to do that over here. Right. So the other thing you kind of probably have seen, right, is that you can directly type your commands into this console. That's fine if you're doing something really simple. If you're typing in a few lines of code, my suggestion is actually to use an R script. So for this particular tutorial, right, there is an associated R script. You could download that and load that already. And hopefully you've also downloaded the associated PDF to follow along. So to open an R script, click on File, go to Open Script. And if you've already set your working directory, this will open up to your working directory right away. And so that's the R script that I'm using. And so this is basically like a text file with all the code that I've already typed in. It's a lot easier to edit code if you made some mistakes. Rather than trying to fix it in the consoles, it's very difficult to do it directly into the console. So this is like a text file, and you can very easily change your code, edit it if needed. So these are like text files. So let's say you want to save it. So let's say I wanted to create a new script, and I type whatever I want in it. And then if I want to save it, you can just go to File, Save As, and whatever file name you want. Make sure the extension is a .r extension. This is going to be a .r extension. Okay, so that's just one thing to be aware of. And then you need to open R to directly open the script that you saved. So this is the script that I've used. You can follow along a little bit. So the file name that we're using is this file called purity.txt file. So to be able to read in this text file, I've already saved this text file into my working directory. So that's what I'm using. So that's why, right? You notice when I use the command read.table, R is assuming you want me to input this file from the working directory, right? There's no way for you to specify otherwise the working directory. So if you have a text file, I'm putting header equals true here because I've already opened up the text file and I've seen that the first line of the file is the a heading, right? And basically when I put header equals true, I'm telling R that the first line of my text file is the heading, right? And it's not really a value in the data set for you to read it. If you have a text file, this sep is called separator, right? If it's a text file, it's always sep equal sign open and close quotes. So let me just read this in. So if you want to read lines in rather than typing the whole thing out, you can just block it all and then press Control R, and R would just execute that command, right? So it's reading it in. As I said, the first line is the headers. The first line is the header, so I'm telling the computer to not treat the header as part of the data set, right? It's just like a label. So once I read this in, it outputs the contents of the data file. Now, obviously, what we're going to do is we're going to fit linear regression models, right, to this data set. We're going to do plots, create different plots with this data set. So you want to do things associated with this file. So you might want to do something like write a line of code like this, where I'm basically storing this data frame into this variable called data. Right, so let me just read this and execute this line. Right, notice it doesn't output the data file right away. So we could store this into this data frame called data, and we are just working with it. So a few things you could do, right? You could always say, well, I've stored read.table inside this variable called data. What actually can I extract from this variable called data? So if you want to see what you could extract, what are the components associated with this thing called data, I can type in names data. And this tells me the two things I can extract are purity and hydro, right? Which isn't that surprising because those are the two columns associated with my data set. So if I want to just look at the contents associated with one of these variables, maybe I just want to look at the variable hydro, I could type in data because that's the name of the variable. So data $ means I want the component called hydro from data. And I run this code and it gives me the values for hydro. So that's one way you could do it. Another way to extract some of these components from a data frame is you could say, I want to make this thing called data my default data frame. So I'm going to use the command attach data. When I do that, I don't have to type in data $hydro to extract the variable hydro. I can just type hydro, and that will give me the values of the variable hydro. Right, so this might save a little typing. So this is something you could potentially do. So I don't have to type in data $hydro to get this. So this is useful. One thing I would say is that if you're working with multiple data sets, I will not encourage you to use the attach function, right? Because it can get a little confusing over there. If you want to remove data as the default data frame, I can use the command detach. And if I type hydro again, you will notice that it says I cannot find it because it's no longer thinking that this thing called data is the default data frame. So when I type in hydro, it doesn't know where to search hydro from. Okay, so I'm going to reattach data so that I can easily, conveniently recall these variables. So the next thing that we can do is to create a scatter plot of purity against hydro. So the data set is from a chemical experiment. It's looking at the purity of the output based on the percentage of hydrocarbons in the condensing unit. Okay, so we're trying to say maybe plot how the purity of the output based on the amount of hydrocarbons. So the purity variable is going to be the response variable, the hydro variable is going to be the explanatory variable. So to create a scatter plot, the function that we use is called plot. For every function, you have to specify arguments in it. So in this case, there are two ways to specify arguments when you want to create a scatter plot. You could list x variable, comma, y variable. So that's one way of doing this. I could just run this code and this will produce the scatter plot. Another way is I use plot and then y variable tilde x variable, and it will produce the same plot that I have, right? So you can always go to Windows and look at the graphics. So this is the graphics that was produced. So sometimes, a lot of times in R, there are actually maybe several ways in which to produce what you want. Sometimes it's just an issue of which one you're more comfortable with. So you notice in that plot, right, there wasn't any labeling associated with my x-axis, y-axis, and the title of the plot. For now, this was a very simple example, so maybe it's not so crucial. Later on in the class, you'll be producing a lot of these plots, and it's crucial that you label all your axes and your plots so that it's clear which plot represents what. So there are some additional arguments you can add in. xlab is basically the label for the x-axis, ylab the label for the y-axis, and this main is basically like the title that you want to put on top of your plot. So I'm going to just run this line of code, Control R, and you notice, right, it basically gives me more descriptive names of the axes as well as the title associated with this plot. Now, some of the things you could do is very often you'll want to save the plot, right? You might want to save it to a JPEG file so that you can add it to your document that you're turning in for your homework. If you want to save a plot to, say, a JPEG file, you could use this line. So this line basically tells R that I'm going to save this plot as a, the name is going to be join.jpg, right? And some of the things, also before we go there, some of the things you could do is, if you want to look at plots side by side, you notice in the previous plots we were producing them one at a time. If you want to produce two different plots and put them side by side, you could split the plotting device. So I'm going to use this command that will split the plotting device. And this part over here basically means I'm splitting the plotting device such that it will produce the plots in a 1x2 matrix, right? So it's going to produce it in one row and two columns. I'm going to run this, so nothing's produced yet. And then I'm going to create plots, one for each variable. Right, so if I just run the first line over here, this produces the first plot. If I go back to my graphing device, so right, it's going to be producing it in one row and two columns. So this is the first plot that's produced, and if I want to produce the next plot to put it side by side with that, I can run that code and I can see my plots over here. So this is how you could, right, if you want two plots side by side, right, I want to produce the plots in a 1x2 matrix. That's how I could using that par mf row function over here. The next thing I wanted to talk about, right, is if you want to save the plot into a JPEG file, we could use this command. If you want to save it as a PDF, you could change this to PDF and then joint.pdf. So I'm going to run all this. So notice these three lines of code are exactly the same as the previous three lines, right? So I need this line here to tell R that I want to save this plot as joint.jpg, and this line, last line over here, actually produces the file, right? So if you don't type in this dev off, it would not produce the file. So let me just run all of this. If you run all of this, it actually wouldn't produce the picture for you, I believe, right? It's not produced. You notice under Windows, the graphing device wasn't produced. If you want to go into your working directory, let me just open it up. Notice that that's the joint file that I saved, and it's saved over here, right? So this is just one way in which you could save files. Okay, so let's just go back here, right? So these are just some basics in which you could use, right, to save some of these files. Now this is a regression class, so let's just go in and talk about some things that you can do in regression. So to fit a linear regression model, the function that we use is lm. And then the argument is going to be the y variable tilde the x variables, right? So lm stands for linear model. Run that, it gives you the intercept and the slope, right? So that's intercept and that's a slope. Now, again, you might want to store the results of this linear model. So I'm going to store this inside a variable called result. So whenever I want to store something into a variable, I use this like arrow sign over here. So it's basically like a less than sign and then a minus sign. I could use the equal sign on my keyboard, but I don't like to do that. The reason is you use equal signs a lot in arguments, something like here, right? So another thing in your plots over here, your arguments use equal signs. So I want to separate the signs that I use for my arguments versus my variables. So I use this. So this is like the less than sign and then a minus sign, it's like an arrow to do the assignment for a variable. So let me just run this. I'm going to store the linear model inside this variable called result. And I can type in summary result and that gives me a lot more information, right? It gives me the standard errors, t-statistics, p-values, and we'll talk more about these in the next video tutorial. To produce the ANOVA table, right, we will just type ANOVA and then our linear model that I stored inside results. So if I just run this gives me, that's the first line is the sum of squares regression, and that's the sum of squares residuals. By default, R doesn't produce these total sum of squares. That's just one thing to be aware of in R.